the session of the evening. This session is about the smart everything. Before starting the session, I wanted to give you a small, short tutorial on geography. Okay? So, last year I presented myself and I told you that I was... Last year?
Use the main the two macros. Next to you. Take the other one. In front of you.
Hello?
Yes. Yeah. Perfect.
So last year I told you that I was coming from the University of Cadiz and that Cadiz was the eldest city in Europe. This was a bit controversial because everybody had an eldest city in their country. So I did some research and I can confirm that Cadiz is the eldest inhabited city for a long time in Western Europe. So this year I will present the following two presenters from another parts of Spain that you probably might not know because probably you know Málaga, Barcelona and so on and so forth. But we also have our first presenter will be from Albacete, that's also a region inside Spain, and that which origin is not clear, it's not as old as Cadiz, but it's from the Arabic area, from the Arabic years. And also our second presenter is originally from Murcia, from the University in Murcia, that is also an area in the coast, and which is also a city originated in the Arabic years, around the year 800, even though he then moved also to Cadiz. So now that I have given you a short overview of where we come from, I'm going to present our next speaker. So our next speaker is Elena Navarro from the University of Castilla-La Mancha. She comes from Albacete. She is full professor and she has already been living in Greece because she got a research grant from the EUA to do some research a few years ago, right? She's involved in many research projects and she has also been program chairing some important conferences like ICSA, and is mostly interested in software engineering and software architectures, in particular related to its health issues. And today she's going to talk us about digital twins that she has been working on in the last few years. So
first of all, with the text for introduction and just one thing. No? Do you hear me? No? Don't have the battery. No, it's okay. So I will start with this one. So, first of all, just a hint about Albacete. We are not very well known because our historical places, but we are very well known in Spain because our fair. It was selected twice the best fair in Spain. And we were not the only one voting, so I was suggesting you to come. If you are in Spain in September, you are welcome to come, and I'm sure you will enjoy there. Okay? So, first of all, I would like to tell you that my talk today is just an introduction to digital twin, a brief overview about the topic, and also my goal is that to present you some research questions that I think that in the next year are going to be solved. Okay? So this is basically my goal today. So first, go to an introduction about digital twin. If you have a look, you look for a definition about digital twins, you may see that there are many different definitions about the term. For instance, Andreas has collected 112 different definitions about the term. So there are many different approaches to the problem. But we have really focused on one definition that, provided that we are an adult, that describes the different types of digital twins that you may find. So first of all, considering that you have a physical twin, an element that is going to be monitored, you may have a digital model that has not a real connection with the physical twin, but it's going just to be a digital representation of this element, being the physical twin just an element, a process, or a system. Then, in case you provide an automatic flow from the physical twin to the digital model, is whenever you are speaking about a digital shadow. In this case, your digital representation is going to mimic every one of the features, the states that your physical twin is going to have. So, in this case, there is no real connection between your digital shadow and your physical twin. So I think the other aspect that you are considering whenever you are speaking about digital twin is that you don't have only the digital representation, the synchronization between both elements, but you have an interaction between both elements, between the digital twin and the physical twin, so that at the end your digital twin is going to be able to control as well the physical twin. This is basically the difference. And I think that it's quite important to know what's your approach to the problem, because it's going to define the complexity of the development, and it's going to help you to define the functionality that your digital twin is going to have. So at this point you may ask yourself, do the digital twin exist really? So if you have a look in different literature reviews, you may see that only in the first cross-domain approach, after analyzing 356 different proposals, only 20% of them were really digital twins. They were really providing this facility, but only in the manufacturing field, only 17% of this one. So I feel that this should be something that is quite important, that whenever you are going to design your system, first consider what you are interested in really. Okay? So, but digital twins have promised many benefits in your development. In different tutorials, in different blogs, you may find many different promises about the use of digital twins in your development. They say, one of them says that you are going to increase the efficiency of your system in 50%. You are going to reduce your maintenance cost in 13%, and it's also promised that the investment in this area is going to increase gradually during the next year. So if you see, it's expected that we are going to pass from $3.5 billion till $73 billion in this year, in 2027. So thanks to this promise, I think that's why, as you may see, the number of papers in this area has increased dramatically. So just the latest year, you may find in Scopus 7,271 different papers about digital twins. So as you may see, it's attracting a lot of attention, this concept. So all these promises, all this attraction has made that they are being applied in many different domains. For instance, in manufacturing, they are being applied for many different things. For instance, for scheduling optimization, how I have to plan how a product is going to be developed in a factory, and how, for instance, I may use deep reinforcement learning in order to improve all the knowledge we have about the factory and improve the process. For instance, also using artificial neural networks inside the digital twins, we may conduct some kind of quality control in the products that we are creating in a factory. And also for the prototyping, they are quite be used. If you have a look in these topics, in prototyping, in quality control, and scheduling operation, you will see that most of the works in this area are not really digital twins, but are really digital models. So basically they are using the digital twin to simulate the behavior and train the deep reinforcement learning algorithm, the neural network, etc. And also they are quite being used in the prognostic and health management aspects in order to detect any kind of future failure that can emerge in a machine. So I suggest you to have a look in this work regarding Tao, because it's one of the best, most well-known works in the area. In the agriculture as well, they have been used in order to optimize different aspects of the agricultural process, like irrigation, resources use, even how to work with the machinery, the crop yield, etc. Even as you see, even for the animal welfare, they have created digital twins for cows, so that they are going to monitor the cows in order to know if they need some kind of medicines, if the animal, all the feeding is properly done, a lot of things there. And even for urban planning, they have been used for city infrastructure, traffic flow optimization. They are being used even to create better communities, and you can have a look of different digital twins that are being developed currently for different cities like Singapore, Turkey, Australia, etc. And obviously in the healthcare domain, they have been used as well for the design of drug developments, for the design of virtual organs, to plan how you should be dealt in a hospital since you arrive to the hospital till you leave the hospital, and even for the disease control and prevention. I don't know if you perhaps remember COVID. So for instance, we were using digital twins to monitor the users that were living in a nurse care center in order to detect whether they may be suffering COVID, to isolate the people. So as you see, they are using in many different ways. But I would like to add another one, that is information and communication technology itself. As I already said, they are being used quite a lot for training, for instance, artificial neural networks in order to provide a simulation, or for instance, in genetic algorithms. As you know, you have to adapt, to customize the parameters of the algorithms, so they are being used to help in the process of customizing these algorithms. And recently, thanks for the talk last Wednesday, there is a very recent work about digital twins and distributed artificial intelligence for edge computing. And now they are using digital twins for every one of the edge device, edge nodes, and edge servers that may arise there. And they are going to simulate how these devices are going to work in order to optimize how you have to deploy your distributed artificial intelligence. So as you see, there are many different approaches where you can use digital twins. So one of the main problems that we have detected whenever we are trying to develop a digital twins is that the development itself. So if you have a look in most of the literatures in the area, they claim that there are no approaches, domain-agnostic approaches, that guide the development of digital twins. Most of them are focusing on just on a specific domain. And there are no approaches about how to validate and verify a digital twins. Also, how to maintain the digital twins, or the standards that you may use, even the frameworks that can be used for the development of digital twins. So there are some ideas, only some agreement about the elements, perhaps the one provided by Tao that says that one of the components should be the virtual entity, the physical entity, the data that is going to be collected regarding the physical entity, the synchronized between them, and the service that the digital twins should provide, but no more about this topic. So considering this aspect is why we decided to approach the problem of the development of digital twins. In this sense, first of all, we have to consider which properties a digital twin should have. So, for dealing with this problem, first of all, we found the paper provided by Roberto Minerva. They analyzed more than 300 different approaches to the design and development of digital twins. And thanks to this analysis, they found out different properties that a digital twin should satisfy in order to be really considered a digital twin. So as you may see, they consider 3 essential properties that a digital twin should always satisfy, that are representativeness, reflection, and also entanglement, and other properties that you should consider whenever you are going to design a digital twin. You don't have to satisfy all of them, but it depends on the needs of your system, the one that you are developing, is when you have to identify which properties you are going to focus on. So considering this aspect, we have, in our group, we have approached the problem from 2 different perspectives. One of them is the development of digital twins considering multi-agent systems. We have analyzed in this work all the properties that a multi-agent system may have, and then we have analyzed if these properties may be used for the design of digital twins. And we have identified that most of the properties can be satisfied if you are using a multi-agent system. But we have also identified that most of the papers that we analyzed didn't exploit really the multi-agent system facilities to provide these digital twin properties. So we think that this is a very interesting approach to be followed in the next future. And then another approach that we are analyzing is the use of domain-driven design. Perhaps you know domain-driven design. You know microservices, I suppose. And then you may ask me, why? Why domain-driven design? Okay? You don't ask me. I suppose why. Okay, so our hypothesis about the topic is that digital twins should be considered and should be developed as system of systems. So every digital twin should be developed and created like an independent unit that should be independently deployable, independently governed, independently runnable. So at the end, our digital twin is not going to be just one digital twin, but a community of digital twin. Because in the work we have analyzed, we have found out that at the end we have come to exactly the same problem that almost 10 years ago, that digital twins are being built as monoliths again. So our idea is to break the monolith and use the domain-driven approach as one of the ideas to build the digital twins from a different approach. So in this case, I'm going to speak about my book, sorry. And why we are using, I'm going to describe this proposal is basically because it's domain agnostic. It's not related to any kind of domain specifically. We are not providing any implementation detail. So we are identifying just concepts to be considered whenever you are developing. And we have also empirically evaluated the approach to the moment regarding the Taos proposal. And the results are statistically significant, so I think that we are on the good way. And also, we have not defined this proposal from scratch, but we have considered the conceptual framework that was provided by Minerva to define how to guide the process. So, basically, as you know, in the domain-driven approach, we have to follow 2 different stages. One of them is the strategic design, and another one is the tactic design. So basically, in the first stage, in the strategic design, is whenever you are going to identify the types of digital twins that you are going to create. And then in the next stage, in the tactic design, you are going to create the architecture for every one of the types of digital twins that you are going to create. So basically, in the strategic design, as I said,
What is the difference between internal structure and domain model? Last slide.
the difference between
Internal structure and domain model.
internal structure, okay, because in the external structure we are focusing on the design of all the system. And if you remember in the domain-driven design, we have like splitting the design in different layers, and at the end we have to separate anything regarding.
I will not. Thank you.
Okay. So basically, in this case, we are going to first of all to identify the types of we identify the digital twins, the objects that we are going to create a digital twin for. Then we identify the types of digital twins, and finally, which type of connection we are going to need between these type of digital twins. So basically, for instance, in the case of a wind turbine, first of all, you have to identify every one of the elements that are going to be part of your wind turbine, so that they are identified, and then you are going to identify, for instance, the types. Okay, so for instance, you see that I don't know what's this. The sub, you see that I have different subs. They are instances, so they are digital twins. So I may identify one type of digital twin that may be a sub. Okay? And also, for instance, you see that you have the wind turbine and the electronic controller. So in this case, for the design, we decided that the wind turbine will be like a composition between the wind turbine and the electronic controller. Both of them has been controlled at the same moment, at the same time. You must maintain the consistency between them. So once you have analyzed all these elements and you have identified the types of digital twins, then you define for every one of them its design. So you conduct for every one of them the tactile design. So in this case, as you see, we have identified for every one of the properties that Minerva's identified one archetype from the domain-driven design that may be used to deal with this property. Okay? So you see that also we trace every one of these properties to one element of the architecture. So at the end, you are going to have like a decision tree that you may follow in order to decide what I'm going to need really for the system I'm developing. So first of all, the first properties that obviously whenever we are working with a digital twin we have to focus on is representativeness and contextualization. Obviously every one of the features that are relevant for my digital twin has to be properly defined in my system. But it's quite important that also we have to consider the context where my digital twin is going to be defined, is going to be created. Because it's quite important that your model must have a high fidelity definition, but only the one that you really need to the problem to be solved. So you have to consider the context of use to select properly these types of features that you have to include in your model. And also the reflection, so that every one of the values provided by the physical entity is timely represented in your digital twin. So considering these aspects, our first idea was that everything regarding to the description, the model definition of the element to be twin has to be defined in the domain layer. So you have to focus just on the domain, just on the problem you are working with, and identify every one of the elements. So if you remember, if you are using domain-driven design, you may use entities in order to describe any concept that is going to be univocally identified, value objects to describe any complex property that your digital twin may have, and also the aggregate. Okay, so if you remember, I said my wind turbine was going to be composed by both things, the wind turbine and the entity controller, electronic controller. So all the information that we obtained during the first step, the strategic design, was coming later on here in the design of the tactile domain. So once we have defined these properties, the next properties that we may consider whenever we are defining our digital twin are augmentation and accountability. So our system should be able, obviously, to provide facilities that the physical twin many times don't have by itself, but are going to be provided by the digital twin. And also the accountability means the abilities to facilitate that your digital twin is going to manage any damage that your physical twin may suffer, but also the digital twin itself. So in this sense, I want you to call your attention, because till the moment there are no proposals describing how you have to describe, to create your digital twin in order to provide these facilities, how I may follow an approach that facilitates that finally my digital twin may be reusable. There are no proposals in this sense. So we consider that this is something that should come from the requirements stage. Until the moment, no proposals on this side. And also, there are no proposals, scarcely some of them, that provide some building capabilities that helps the digital twin to control by itself its health. There are no proposals in this sense. You may find a lot of works that are exploiting digital twins to control the health of some systems, but no facilities to control the health of the digital twin by itself. So, in this sense, our idea was that the application service layer may be used in order to define properly through the use of APIs the different business use cases that may be provided by the digital twin. And also, this is going to be responsible for notifying any one of the changes that are required to the environment. And also, in the definition of the digital twin, we should think about anything that we are going to need regarding the health of my digital twin and the health of the physical twin score. Okay? So, in this application layer is where we should include all these facilities thanks to the use of a public API. And then, if you have seen, we don't introduce any kind of technical stuff, either in the domain layer, either or in the application layer, but because everything is rely on the infrastructure layer. All the decisions regarding all these properties are going to be in the infrastructure layer. So at the end, our idea is that if we want to change anything regarding the technological approach that we are going to follow, everything that we have developed internally in the model is not going to be affected. So in this case, we can exploit dependency inversion to change anything that we are going to need from the technological point of view. So in this case, this layer is going to be responsible for two different properties. One of them is entanglement, and another one is memorization. Entanglement means that we need to be able to update in real time or near real time, depending on the needs of our system, the status of the physical twin. And memorization means the ability to store any meaningful past and present data regarding the physical twin. So, in order to consider these facilities, if you analyze domain-driven design, you will see that it offers two facilities, that is event sourcing, so that any connection to the external environment is going to be supported by event brokering, basically. And also the use of the repository may be useful in order to deal with any persistency issues that we have to focus on the development of the digital twin. However, in this case, we have a problem with the use of domain-driven design that we noticed, but because the domain-driven design is not thought for dealing with applications that are going to deal with many data, with a great volume of data that must be processed and that must be analyzed and must be fusion, many different things there. So in this sense, we have been working to consider some special decisions that we have to follow during this process. First of all, you have to define whether if you are following a time-based approach or an event-based approach to update the status of your physical twin. This is something that must be decided. Also, during the design of your system, you have to decide if you are going to use just homogeneous sensors or heterogeneous sensors that you have to basically at the end you have to fuse in order to conduct or apply different data fusion level techniques or feature level techniques. And something that we found as well that has not been conducted to the moment is the data fusion evaluation itself. In this sense, we consider that the consideration of the data fusion evaluation could be a first step to solve another of the research challenges that must be solved. There is quite interest in the community to evaluate the fidelity of the digital twin that you are creating. how much and how well your digital twin is really representing the physical twin that you are doing at this moment. So we have done some conduct examination.
Isn't fidelity the problem that you always have if you model data, for example?
The problem is that many times you are simulating the digital twin, and at the end there can be a difference between what is the real behavior and the expected behavior. So you have to check both things.
It's not a data problem, it's a behavior problem.
It's a behavior, but it's also a data problem, because if your data are not properly addressed and not properly processed, at the end you are going to have a problem in the fidelity of your digital twin.
But this is true for any data model.
Yeah.
Okay.
Yeah.
That's fine.
Yeah. But in this case, as we are using a vast amount of data and very heterogeneous data, I think that in this case we have a serious problem if you are not considering this aspect from the very beginning. Okay? So that's why we consider that the data fusion evaluation should be considered in the design of the system. And then we were, in this initial work, we were evaluating the different data fusion techniques that are being applied nowadays, and the different data life cycles that they have been applied. And after a refactoring process, we identify the different steps that may be followed during the data fusion process. So our idea is that this data fusion process should be also part of the infrastructure layer, so that at the end our digital twin is going to be provided with the proper data. Also, we identified that, as I said, there are almost no proposals for the evaluation. So our idea is that as the digital twin is running, automatically you will be evaluating the quality of your data fusion system, and at the end, the quality of the digital twin itself. So in this sense, if you see, we have considered and evaluated that the need of introducing different steps where we are going to store different data and information throughout the process. So automatically, in every one of the steps, you will use all these stored information in order to evaluate automatically the result of the digital twin, the status of the digital twin regarding data. But also we think that something similar could be done regarding the behavior of the digital twin. This is just the first step we are evaluating and analyzing. Okay? And a colleague of mine says, this is the beef of the digital twins. The composability. There are no proposals at all working with this problem. The idea is that, as I said, we are not going to deal with one digital twin, but with a composite digital twin that are going to be used for solving the problem. But not only a composite digital twin, but a composite assembled digital twin. This is one of the most trending problems now in digital twins. Basically because there are many different issues that should be considered if you are going to approach this problem. First of all, reusability. As I said, there are no proposals about how to design your digital twins to be reusable. Not anything until the moment. Security aspect, obviously, because we don't want to have our digital twin, the data that is managing, to be used by someone who shouldn't do it. The privacy of the information that is used there. And the trustworthiness of my digital twin, so that it can be composed with other digital twins to be used in the construction of a general system. Just one of the issues that should be considered whenever you are working with composition is being really addressed nowadays. That is interoperability. Because usually, if you are thinking of the development of digital twin, like a composition of digital twins, you have to consider different interoperability points, both whenever you are going to communicate with your physical twin, but also whenever you are going to communicate with different digital twins that maybe have developed for different purposes. So this is something that is quite important, and because we don't want to have data silos, we don't want to have digital twins that don't exchange its data in an easy way, but data spaces that improve the collaboration between different digital twins. In this sense, I will like to call your attention to some of the efforts that are being conducted from the European Union. They are collecting many different standards for different domains that may be used to facilitate the semantic and syntactic interoperability. So if you see, you have standards for the industrial processes, for robotics, for smart cities, for civil engineering, and especially there is some standard that is quite well known in the digital twin area, that is the 23/24/7 standard that defines both things, the interoperability considerations that you need to consider whenever you are going to create a digital twin, but also a reference architecture. So I would like you to suggest to have a look there if you are interested in the manufacturing domain. So in this case, our first approach to the problem, obviously we have to work on this topic, but we think that the first thing that we are thinking of digital twin as independent microservice. In this case, obviously, we were thinking of the introduction of message support communication among the different digital twins that should be considered. Okay? So, and one of the latest property I want to speak about, I'm not going to speak about all the properties, only the ones that I consider that are more relevant for the community, that is predictability. Okay? Probably you have known, as I said at the beginning, that digital twins have in the smart abilities very special need, because we need that our digital twins are able to learn, are able to reason and planning in order to provide different facilities for the optimization, for prediction, forecast detection, etc. In this sense, as I said at the beginning, I want to recall that digital twins are used basically with two goals. You see, I have differentiated both of them because they are used many times just to train artificial neural networks for developing evolutionary approaches, but they are not really used, the real data are not really used. Only some of them are really using the information coming from the physical space in order to conduct both things, to train the models and also to provide the output so that you can optimize the system, provide for prediction, etc. I don't want to go, well, in this case, in the design that we propose, we have proposed that there are two places in the architecture, two locations where you can introduce this predictability. One of them is in the domain services, so that at the end your smart ability is going to be able to use all the information that is related to the domain, or other alternative could be use the integration services in the infrastructure layer so that we may use and exploit existing systems, so for instance a test bed that can be used to simulate the behavior or to use different types of neural networks. So we are going to separate completely everything related to the use of these smart abilities from the system. Okay? I don't want to go through all the different types of artificial neural networks that are being used in reinforcement learning, many different things that you may do regarding artificial intelligence. But I really think that one of the issues that must be solved in the next future is that if we are thinking of communities of digital twins working together, I think that we are going to need some way of working with collective intelligence, so that we can have like fleets of digital twins, similar digital twins, that are working collaboratively in order to optimize or provide a solution to the problem. And also, digital twins, diverse types of digital twins for this problem. Till the moment I have not seen this approach. And I think the problem is coming because of the composition problem. And I think that in the next future, this is going to attract the attention of the community. That's why I wanted to recall your attention here. So, what should I do if I want to build a digital twin? Now imagine that you really like it, digital twins, and you decide, okay, tomorrow I want to start to develop a digital twin. Okay? So there are different approaches. For instance, in the Wimmer's work, the latest work, they analyze the different toolings that are used currently in the development of digital twins. And you may notice that most of the papers that they analyzed, they were using just 3D models. So, you think that this is a data model, a digital shadow, or it's a digital twin? What do you think? A 3D model? You think?
Also digital twin. In manufacturing, they have steps.
Most of the papers were not really digital twins. They have just a digital representation of the.
In manufacturing, you have PDAs and steps. These are data representations of automotive parts and so on.
But the problem they detected is that at the end they are not connected to the physical world. These are just a data model without any connection.
Glorified data model. But isn't that an API question? You have the data, like object design, you have the data.
Yes, technologically it can be done. But the problem is that it's not that. Okay? And also, as you may see, many approaches are developing the digital twin from scratch, using, as this morning was said, Python as one of the favorite languages to develop the system. And also some kind of model-driven engineering approaches like UML, CSML, mathematical models, or some kind of simulation tools. But if you are focusing and you want to look for a real framework for developing digital twins, one of the best approaches that you may, the best framework that you may use if you are focusing on the manufacturing world is the Asset Administration Standard that has been developed by the Fraunhofer. So basically, in their approach, they define the entity that you want to model, and then this entity is defined as an asset that you are going to incorporate in your AIS in the past. And then it provides different facilities that allows you to modify your model once it's already deployed. And you see that it also provides different bases for the persistency of all the information that you are going to use. And you see that it's providing support for MQTT and OpenCI for the automatic update of the model that we are supporting with this framework. And something that is quite interesting is that it's supporting the standard I told you about the digital twin, so that many things regarding the interoperability are already dealt with this, the use of this framework. That's why I think that this is quite interesting to be used. And also it can be used using different approaches like Docker or embedded, but according to the documentation, if you have a look for some problems, they don't implement any kind of security mechanism. Okay? If you are interested in the smart cities world, perhaps you may have a look in one of the initiatives of the European Union, the EIF4SCC. Okay? They provide all the principles that you should consider whenever you are going to start to build digital twins for smart cities. So I think that this is quite interesting. And if you have a look, they have paid quite a lot of attention to the interoperability problem that I told you at the beginning. Okay? And obviously, you may find commercial tools. This is an example of the digital twin that we developed some years ago. And it has obviously all the potential. One of the benefits is all the potential that Azure has. And the problem is all the potential that Azure has. Obviously. if you have worked with Azure, you will know that there are many different ways of doing exactly the same thing. And obviously, the problem is that the cost is obviously not the same one. So it's a very powerful tool. If you are interested in developing something very complex, I suggest you to use this one. But something that I really don't like is that if you go there and you look for digital twins, you see the yellow square in the middle. This is the only support that they are going to give you for digital twins. So any other type of support regarding events, update, processing, etc., must be done by yourself, and you have to identify which support from the cloud must be used to develop the digital twin. So it's doable, but it's not easy. Okay? And in this case, I was very lucky because I was working with two students who are software architects in Azure. So I was very lucky in the design of the system. Okay? Another interesting approach, another interesting framework that you may use is called Ditto, Eclipse Ditto. It's very interesting because it's also an open source framework that helps to the construction of the digital twin. And basically, it's going to be able to provide like an agnostic layer, so that it is basically the in charge of the entanglement of the physical twin and the digital twin, so that it facilitates that you can update automatically and mimic the status of the physical twin, thanks to the use of Ditto. It provides some kind of different types of connectivity for IoT devices, and also for robotics through the use of Hono, and to the IoT devices through the use of Mosquito. And as you see here, you have different options to build on top of Ditto the application that you are interested in.
Is there a need to use both?
No, you can use whatever you need. Okay? And this is a very good approach. The only problem it has, and I know recently one colleague from the University of Malaga have tested the application in order to create very complex digital twins, compose digital twins, and the framework is not scalable for this kind of problems. So it's a very interesting approach, but if your system, you want to develop a complex digital twin, perhaps it's not the option to be followed. And they were speaking with the developers of Ditto, and they said that they are not thinking of expanding Ditto for these kind of things. But this is a very good proposal for a start with. Okay? And finally, perhaps you know, Fireware. Okay? This is a very good approach. Some people are starting to analyze. I have seen some papers that they have started to analyze whether this proposal may be used for the construction of digital twins, but they are initial ideas. So I cannot tell you, and I cannot promise you anything regarding Fireware, especially Lupe, when I told her that perhaps she could use Fireware, she was trying to kill me at the very moment. So perhaps it's not the way that you should follow. But just think of it and consider it in the future. Okay? The good side of Fireware that I like it is that they propose automatically smart data models for specific domains that may be used by default without much work on your side. So, conclusions and challenges. So, as I have told you, there are many problems still there to be solved. There are, although we have published like 7,221 papers till the moment during the latest year, there are many more to be done, especially on the re-engineering of the digital twins. To solve many of the problems I have told you, basically we need more tools and methodologies, we need process that guides in the process to deal with interoperability, and especially to deal with the digital twin composition. I think that here is one of the topics that must be addressed in the next few years. This is my 2 cents on the topics. So that's all. Thank you so much.
one of the fundamental issues with digital twins is the problem that they don't learn.
Yeah.
You were mentioning it briefly, and mentioning in the context of collective intelligence, which I completely agree. But actually, even without collective intelligence, you still need, even the individuals to have some mechanism for learning. Are there papers out there speaking about learning?
There are some seminal works that are dealing with the learning of the digital twin, so that they are introducing some kind of reinforced learning in order to facilitate that your digital twin is able to learn throughout the process. Even we are now working something strange because our focus basically is on human digital twins, and we are trying to introduce reinforced learning so that our system, our digital twin, is able to learn from the behavior of the children in a school.
Because active influence, I don't know if you have done on Wednesday or what an active influence-based learning would be, because it's actually the way to learn.
Yes, there are different approaches that must be followed in the next future, and I think that I totally agree with your idea.
A couple of questions. Rachel,
a couple of quick questions. One is a great summary of the different types of twins. One of the things I'm still struggling with is what's trying to solve? What's the actual fundamental thing it's trying to solve? Which is it a preventive aspect in healthcare? Is it efficiency in manufacturing? So it's not very clear, because if I remove digital twins, I still have the same problem to solve, right? So I feel like it's a concept that's introduced and it's making things a little confusing at times. That's one. Second question I have is, there's a lot of interest in moving to, can you make the twin a little bit more human-like, which is, speech, video, multimodal, which is missing from a lot of the publications. But you see a lot of work coming out, at least from California, and where they're trying to implement, robotic systems, which are practically digital twins, with a lot of video front ends, speech front ends, converting speech to text, text to speech, which means that you'll see a whole new world of digital twins come out in the form of physical robots or whatever, right? And they're present at the factories or machines or whatever it is. So these are the two questions. So I'm still starting with the first one. The second one, I understand, it's an implementation issue.
So I think that the first thing that we should decide is that which type of digital twin you are going to need. I think that this is the basic confusion that we have whenever we are speaking about digital twins. Because many works we have been reading during these months, during these years, they are not really digital twins. They are just dashboards that are showing some information. The problem is that it's very trendy. Now, if you use your word digital twin, it's like you have something very interesting. It's like large language models or blockchain, or this is a very trendy approach. But the problem is that, first of all, we should decide what digital twin is and for which type of problem we should use. This is something that it must be considered. That's why we thought that the use of this theoretical framework can help to know if you are going to design a digital twin. First of all, decide which properties you should have. And if I have these properties, this means that I'm really using a digital twin. That's why we thought that this was the best approach to the design of digital twins. And second one, regarding the type of interaction. I think that the problem that we are having in digital twins is that requirements engineering doesn't exist. Doesn't exist at all. Most of the proposals related to digital twin are coming from the engineering world, where there is no connection, there is no information about software engineering. So I think that we should make some efforts on this side in order to properly identify these facilities. This is something that you may need, so that whenever you create your digital twin, you provide also in your business use case these facilities that you are going to need. So you have to consider this one from the very beginning. And I also agree that we may include in the digital twin facility that help you to communicate directly with it in case you need it, but only in case you need it. No.
But there's going to be a massive shift in using multimodal, multimedia applications.
Yeah.
Because it's coming.
Yeah.
If you talk to my friends in NVIDIA, I'm sure they talk about all kinds of robotics
Yeah.
interfaces and able to digest, which means that APIs have become more multimodal in nature. So it's not very clear in my thinking that the previous work is really going to transform itself into new kinds of things that are coming up.
Yeah.
So if you want to take the new things in,
Yes,
it's
you
now
have.
on a whole new framework, whole new architecture,
Yeah,
right, that use multimodal.
yeah,
Like whether they use that, it doesn't matter. But also it's another
yeah.
constant phase right now, like because the other things are not that happening.
I totally agree with you.
Thank you very much. So sorry to say that we have to wait a bit more for the coffee today. The coffee is after the second talk.
Keep smiling.